Hello and welcome everybody. My name is Alexandra. I'm the new resource soil scientist for the Natural Resources Conservation Service based out of Harrisonburg. Today I'm going to share some information with you all on how to access the soil survey, data for your land, and just understand how to use it and interpret it. I was asked to share some basic soils information, but I think giving you the tools to find this for yourselves will end up being very useful. So I'd like to do today. I'm using my coworker's property in Rockingham County. It's about 35 acres as an example. So while it seems like this is tailored to his site or the Ridge and Valley, just know that you can use the same methods to find the information for your own site, regardless of where you are in the state or the country. Let's get into it. We're going to start by using Web Soil Survey. You guys have seen copies of the soil survey before. They're usually, they might have a county or two in them. And if you're not familiar with the soil survey, in the past century or so, huge teams of soil scientists came and mapped the soil resources we have across the country. There are a few areas that are still yet to be mapped, but in the state of Virginia, everything is basically done. Just a great resource so we can best use our soils. So here's the main page. The trickiest part is drawing your area of interest, which is going to give you, the specific soil information for that area. Just play around with it. It can be a challenge at first, but once you get used to it, it's pretty easy. I'm going to be using a zip file just for the sake of convenience here. But essentially the goal, as you can see here, is to draw the polygon that best represents the area you want information for. So this ends up being about 37 acres for the tract that we're looking at today. You can also use these quick navigation tools to make it a little bit faster getting to where you want to go. But you can also just zoom in and pan with these buttons up here. Once you have your area of interest drawn, and it should be, with those blue hash lines, we're going to look at the soil map. The soil map is going to bring up the types of soil found within that tract. So here we see that the most dominant soil is this Weichert-Berks complex. 45 to 70% slopes, extremely stony and eroded, makes up 94% of the tract. We also have some more Weichert and Berks soils up here. So overwhelmingly, this is the dominant soil type. We have a little bit of this Craigsville, but that's really out of the area of interest today, even though it's part of the tract. So this is what we're going to be exploring. You can click on that, and it'll break down what those types of soils are. So the fact that it's a Weichert and Berks complex means that these soils are so closely associated, they were unable to map them separately. So they just left them in one unit. Weichert here is 60% of this map unit and Berks is 30%. It'll then go on to explain what a Weichert soil looks like. So we can see here that on average it's 18 to 28 inches to bedrock. So it's pretty shallow, not well developed, and very stony. Give you a little bit more information, somewhat excessively well drained, very high runoff. No frequency of flooding or ponding due to its deepness. Then it goes into the Berks series, same thing here. We'll touch on this later, but just know that the difference between the Berks and the Weichert is that the Berks is much deeper. It's still very shallow, 36 to 46 inches to bedrock. But as you may guess, since they come from the same material, mapping these out separately would not really be possible. So we have a complex. One other thing to note is that the soil map may not be valid at this scale. This was mapped at 1 to 20,000 scale. So when you zoom in closer to that, these lines that the soil scientists originally drawn, they might move around. So you just want to take it with a grain of salt. This is just a general map of what is here, but when you're outside of that proper scale, it's a little bit skewed. So once we've looked at the soil map and we can see what is there, let's understand what that means. So on the Soil Data Explorer tab and Soil Properties and Qualities, we can actually look at some features of this soil. So let's start by looking at depth to any soil restrictive layer. No, I'm sorry, selected soil restrictive layer. We're going to look at lithic bedrock, and we're going to view the rating. This is going to show us that on average in this Weikertberg complex, we have a 46 centimeter depth to bedrock here. We can also look at the drainage class. And we can see that this soil is rated somewhat excessively drained, which we saw earlier when we clicked on the map unit, but it's nice to just see it again. And what else do we have? Water features, depth to water table. We'll view that rating. And it is greater than 200 centimeters. So when you're trying to plan out, maybe putting in some logging rows or some plantings, using these tools is very helpful to maybe stay out of wet areas. It's also nice to note that you can create a printable version of this information. Just creates a nice PDF that you could share with anybody who might need to see this information. It's all the same stuff we just looked at, but in a very nice little package. The other option is to add it to a shopping cart. So you could add multiple of these outputs into that. So you have a quick reference with all of that information in there. We'll do one more. We'll do a chemical property, maybe pH. We're going to look at all layers and the weighted average and run that. And we can see that this is 5.2 pH for this dominant soil map unit. There is something else we have. It's the suitabilities and limitations for use option. This tab takes a lot of those singular properties and qualities and actually tries to give you a rating. So we can look at construction limitations for haul roads and log landings. And we can see that this was a severe rating due to the slope and the stoniness, and also the dustiness of these two map units. Quite a lot in here. I highly recommend just playing around with it and see what you can find. One thing that might be useful for you guys, and I should add that I am a soil scientist. Forestry is not in my background, but I can at least give you guys the tools to use this info that might be very useful for you. So we're running the tree site index now for Virginia pine. And we can see that for our soil map unit, it's a rating of 60 feet per 100 years of growth for Virginia pine on that map unit. And maybe we'll also do northern red oak just to see what we get there. That one was rated 64 feet. So I hope this, guys, gives you the tools to, move forward with your planning and just understanding of your soil resources, so you can just make good use of them. So what I'd like to do now is show you some videos I filmed at this property, showing that even though we estimate that, there's 60% Weichert, 30% Berks out here, there can be tremendous variation in some of these soil landscapes. So while the soil survey is a great tool, sometimes, there might be a few different things out there. So here we are at our first soil profile. We're here on a north-facing slope. Lane's property, we got a lot of pines on this part of the track. The soil series we're looking at here is the They're both sedimentary bedrock-derived soils, primarily shale. However, the Weikert is extremely shallow compared to the Berks. This site in particular is a little bit deeper than your typical Weikert. I've seen, soil about a foot deep in a lot of places to bedrock throughout this location. So let's just have a look at it. So we have a very shallow topsoil layer, a little bit of organic material going right into the subsoil. With this soil, as you go deeper, you pick up a lot of rock fragments. We got some big chunks of shale in here with just some really large cobbles intermixed. And then we go right into this shale bedrock, which you can see outcropping here on the logging road. So a few important things to consider with this shallow subsoil. There's not a lot of water holding capacity, so these soils may be more vulnerable to drought. In addition, tree roots might have some difficulty penetrating. They do a little bit better with the shale, they can kind of get through it, but overwhelmingly this is a shallow soil. You might see some more tree throw throughout this area. Other things to note, if you have these type of soils, putting a logging road through something that's only a foot deep to a solid bedrock might be a challenge for you. And the one last important thing always to consider with Berks and Weikert soils alike, they're very shallow. Erosion could result in a lot of soil loss here, so preventative measures to keep as much soil in place throughout the logging operations is just critical. Planting a cover on exposed soils, quick growing cover, I think perennial annual ryegrass, water bars, all of those best management practices that you guys are probably aware of. Definitely want to utilize those. But with that being said, this is a very common soil throughout our forested land, so it can be productive with careful management and time. These soils, might take a lot longer till you get a meaningful harvest, but gotta make the best of them. Here we have another example of some Weikert soils. This one is even more shallow than the one we just observed. And as I mentioned at that site, you can have some tree roots that do try to penetrate this shaly material, but definitely with some limited success. Alright, we have one more thing to point out on our way down the mountain. I just noticed this and wanted to show you guys. So here we have a tree that either fell or was pushed down in the construction of this logging road, but here you can see a very clear area where you have roots bent at almost a 90-degree angle, showcasing how root limiting this soil can be when it hits that shale bedrock. Welcome everybody to another soil profile. Here we have the Berks soil series. Like I said before, Berks and Weikert exist both in this soil map unit. It is dominantly Weikert, but we do have 40% Berks soils included, so I'd just like to showcase that to you guys. The most important thing to note about the Berks is that it's a little bit deeper than the Weikert. Still moderately deep, it ranges from 30 to 40 inches to bedrock. But it is the better soil out here in this landscape. So, just taking a look, we have some organic matter accumulation, more of that OI fibrous organic material at the surface. There is a high amount of these very fibrous roots, so underneath that, we get this nice granular topsoil. It's pretty shallow, however, with this high slope, that material will erode away naturally, restricting its depth, but we still have a decent amount of topsoil. Going further into the soil horizon, we get into the subsoil. Now this is still derived from shale material, so you can see some gravels in here. But overwhelmingly, the structure is very fine and not well developed. There's not a lot of clay. So, The increased depth to bedrock, because that comes in here about 1 meter, means, you know, you can get more roots deeper in the profile, but it's still lacking development. With that being said, trees growing in this map unit will probably perform a little bit better just to the increased water holding capacity with the soil and depth to rock. Alright, we are reaching the end of our day here, and I just wanted to point out one more thing before we wrapped up for the day. We've seen a lot of soils that are mapped as the same map unit, but it is important to note that there's still a lot of variation that can take place that's a little bit more extreme than what we've already seen. This cut is in the same map unit as the Berks and the Weichert, but obviously it's made of a lot finer material than what we've seen, and as a result, you have a lot deeper of a profile. Not too long ago, there was some mass wasting here. This all sloughed off and actually pushed against the shop, and the reason why that happens is, you know, we're down at the bottom of the hill. All of the water has moved laterally, can't really infiltrate well with that shaly bedrock, and has pushed its way out. Here as well, there is a lot of actual clay material, which as a result has created an impenetrable layer. So the water needs to come out somewhere. I can actually hear water dripping out of this profile just while I'm standing here. So the action of that caused some mass wasting to occur. Alright, that wraps up all I have to say about the soil here at Wayne's. Just want to let you know you can reach out to your local NRCS field office for more information about your soil resources at any time. In addition, you can also contact your local Virginia Department of Forestry because they can run those web soil survey reports for you too. Thank you.
I hope you've enjoyed the information we've presented today and that will help you further appreciate all that goes on in Virginia's forest soils. Make sure you visit the Virginia Forest Landowner Education Program's YouTube page, and this video will be on that page shortly, and make sure you hit like and subscribe there and tell your friends about it, and that way you'll know about more of these exciting videos coming forth, like Invasive Plants, the third version from Karen Snape, which will be coming up next week on Friday at noon. Thanks. Have a joy-filled journey. See you then.